Good evening to everyone. See this. In this today's live lecture, we shall discuss the second bit, that is unsymmetric expression for the third order differences, or by using the central difference formulae, we have to calculate the first order derivative, second order derivative, up to the nth order derivative. That means we have to calculate this higher order derivatives by using the central difference formulae. Actually, this is the bit which we have to study, that is unsymmetrical expression for the third order differences. We have seen introduction in the last lecture, we have expressed approximate expression for the derivative of function. Now we have to express the third order differences. Okay, now you know that the numerical differences is the process for finding the numerical values of a derivative of a given function at a given point, which we have studied this in the last lecture. We can find the difference, first order derivative, second order derivative by using Newton's Gregory first forward formula, and these are the first order, second order and third derivative. Also we can find the second order derivative by using Newton's Gregory backward formula. This is the first order derivative, second order and third order derivative by using Newton's Gregory backward interpolation formula. Similarly, we can find the higher order derivatives by using a Bessel's formula. Also we can find the higher order derivatives by using the Stirling's formula. Now today we shall discuss the next part, use of a central difference formulae or interpolation formulae to obtain use of a central difference formulae, interpolation formulae to obtain the derivatives, that is unsymmetrical expression for the third order derivative. You know that, see here, you know that the central difference, we can define the central difference in the form of y, that is a delta yi is equals to yi plus 1 by 2 minus yi plus minus 1 by 2. This is the central difference formula. We can write in the form of a function f of x is equals to small delta f of x is equals to f of x plus h by 2 minus f of x by 2. In this way we can find the central difference formula. Similarly, you know that the mean of mu of yi is equals to 1 by 2 yi plus 1 by 2 plus yi minus 1 by 2. This is the formula for the mean or mu of yi. This is a formula for delta I. This is a formula for mu of yi, means 1 by 2 in a bracket yi plus 1 by 2 plus yi minus 1 by 2. We have seen this formula in the central differences. So we can write mu delta of yi. Now we can find mu delta of yi. So put the value of mu delta yi means, put this mu I as it is, delta yi means yi plus 1 by 2 minus yi minus 1. Now separate this mu on both the function. So mu of yi plus 1 by 2 minus mu of yi minus 1 by 2. आता इथं परत याला अप्लाय करा mu means the mean of two functions, that is mu of yi 1 by 2 plus I minus 1 by 2. So we can apply this mean, that is 1 by 2 into yi plus 1 by 2, okay, plus 1 by 2 according to this definition, plus yi minus 1 by 2 minus plus 1 by 2. So it will be, so we can write this as 1 by 2 yi plus 1 plus yi. So this gives the mean. So we can write, apply this mean for first. Similarly, we can apply the mu for second, then we get the result. Plus yi minus yi will be get cancelled. So we get 1 by 2 yi plus 1 minus yi minus 1. So this is a mu delta yi. Mu delta yi means yi 1 by 2 yi plus 1 minus yi minus 1. Now this is a shift. By using the shift formula we can write this as, यालाच पुन्हा shifting formula मध्ये लिहिता येतं 1 by 2 e of yi minus e inverse of yi. E means the shift operator. So e of yi means we can write yi plus 1. E inverse of minus y, that can be written as yi minus 1. So we can write this as, म्हणून याला आपल्याला असं लिहिता येतं. So 1 by 2 yi plus 1 can be written as 1 by 2 e of yi minus yi minus 1 can be written as e raised to minus 1i. Again there is a relation between e and e raised to hd. E आणि e raised to hd मध्ये पुन्हा relation आहे. So we can use this formula. E means what? We can write this as e means replace small e to the power hd. हे सर्व relation तुम्हाला झालेले आहेत. Already we have seen each and every relation. We have seen each and every relation. So also e raised to minus 1 can be written as small e raised to, because there is one formula that is e equals to e raised to hd and e inverse is equals to e raised to minus hd. So we have to replace these two formulas. So we get so 1 by 2 e raised to hd आठवते का फॉर्म्युला पहा. So hd. So we can write this as yi all since हे इथं रिप्लेस केलं, because e of y means e raised to hdy. Okay, now we can write this again. So delta mu is equals to sine of hd, sine hyperbolic of hd. We can write hyperbolic function e raised to hd. See this, we can write this as, so mu delta, याच्यावरून आपण असं लिहू शकतो, because there is a formula, since sine of hx equals to e raised to x minus e raised to minus x divided by 2. This is the formula for sine of hyperbolic function. So we can write e raised to hd minus e raised to minus hd of y. We can write sine hyperbolic of hd, which is mu delta or delta mu. आता sine of hyperbolic hd चा expansion formula घ्या. We can expand this sine of h x means x plus 1 by 3 factorial x cube in this way, 1 by 5 factorial x raised to 5 in this way. We can expand this mu delta mu is equals to sin hd, and sin hd can be expressed as hd plus 1 by 3 factorial h cube d cube in this way. So we get, आता इथं पहा, जो हायर पॉवर आहे एच डीचा डी क्यूब, थर्ड ऑर्डर डेरिव्हेटिव्ह, फोर्थ ऑर्डर डेरिव्हेटिव्ह, हे रिमूव्ह करा. वी हॅव टू रिमूव्ह धिस. हे रिमूव्ह करून टाका सर्व. देन वी गेट, व्यवस्थित समजून घ्या, सिंपल आहे, काही अवघड नाही आहे. देअरफॉर वी गेट एच डी provided that d cube is the higher order derivative can be neglected. जो higher h cube d cube h raised to 5 d raised to 5 Then higher order derivative, that is d cube, d, these are the negligible terms, so we have to remove this. So we get the final answer 1 by 2 yi minus 1 minus yi minus yi plus 1 minus yi minus 1 is equals to hd. So we can write this hd of yi, which is equals to 1 by 2 yi minus yi plus 1 sorry, and yi minus 1. This is the approximate value of hd of yi. So we can take a delta square. आता याचा आपण delta square घेऊ. So we can write delta square yi is equals to delta of from 1. याला इक्वेशन नंबर 2 द्या. आणि इथं काय आला पहा, hd means delta mu. So it will be delta mu. This is equation number 1. This is, suppose this is 1. This is equation number 1. This is equation number 2. Now we know that delta means here. So delta yi means we can write according to the definition yi plus 1 by 2 minus yi minus 1 by 2. This is the delta y. Now we have to operate again delta 2. So according to this, delta 2 means delta of delta. Delta 2 means delta of delta yi. Delta yi means yi plus 1 by 2 minus yi minus 1 by 2. This is the delta of delta. परत ऑपरेट करा. Delta of y I1 by 2 minus delta of yi minus 1 by 2, it will be yi plus 1 minus 2yi plus yi minus 1. Double delta जर तुम्ही ऑपरेट केला तर या पद्धतीत येतो. So it will be shift operator. So we can write e of yi minus 2 times of yi, and yi minus 1 means e raised to plus e raised to minus 1 yi. You can write this. Okay. Now you take the yi common. आता yi common घेतला तर काय राहतं ब्रॅकेट मध्ये सांगा बरे स्टुडंट्स. इफ वी टेक द yi common here, then e plus e inverse minus 2. So e is replaced by e raised to hd plus e inverse is replaced by e raised to minus hd minus 2 of yi. So we can write this formula. आता याला 2 न डिवाइड करा, 2 कॉमन काढा. So if we can take the common 2. आता याच्या पुढची स्टेप पहा. If we take a common 2, then we get e raised to hd plus e raised to minus hd upon 2 minus 1. But we know that e raised to theta, here e raised to theta, we can write this. इथं लिहितो मी. Cos hx equals to e raised to x plus e raised to minus x divided by 2. So we can write e raised to hd plus e raised to minus hd upon 2. Okay, बरोबर आहे, ठीक आहे. So we can write e raised to hd minus e raised to minus hd upon 2 is cos h e raised to hd. So we have replaced here cos h. हा replace केला इथं. We can replace this as a cos of hd. 2 times of cos hd minus 1. परत आता 1 by 2 cos hd चा एक्सपान्शन फॉर्म्युला वापरा. 2 as it is 1 by 2 h square plus d square. हे डॉट 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 येतं पण हायर डेरिव्हेटिव्ह रिमूव्ह करा. 2 2 कॅन्सल होतं. इट विल बी h square d square yi. This is the value of delta square yi means h square So it will be delta square yi see this is the delta square yi is equals to h square d square yi. Now बरोबर आहे ना. सो h स्क्वेअर d स्क्वेअर इज इक्वल्स टू डेल्टा स्क्वेअर याच्यानुसार आता yi प्लस 1 minus 2yi plus yi minus 1. This is h square d square. We can take this here. Okay. So it will be इथं प्लस पाहिजे. This will be plus. Plus च्या जागी equals to. So we get the relation h square d square yi which is equals to delta yi which is equals to yi plus 1 minus 2 times of yi plus yi minus 1. Similarly, we can write h cube d cube of yi is equals to hd of h square d square yi. Cube काढायचे. So hd आता याची व्हॅल्यू तर माहित आहे. h square d square yi means delta square yi put here. h square d square yi means delta square yi. Again put delta square yi means we can write yi plus 1 minus 2yi plus mu I 2yi minus 1. So we get hd means mu delta. hd means mu square. hd means mu delta. So we can write mu square delta square. So we get this relation. Again we get, so we can write this as mu delta. So expand this mu delta means we will get this again this term. Mu delta is equals to 1 plus delta by delta. So we get 1 by 2 yi plus 2 minus 2 times of yi plus 1 plus 2 times of yi minus 1 minus yi minus 2. So in this way we get, and thus we can find h4 d4 of yi means h square d4 of h square d square. So put this value h square d square means this. h square d square means mu del d square आणि delta delta वापरला तर हे येतं. This is the formula. This is a formula for h raised to 4 d raised to 4. And hence we can write higher order derivatives. So note that y dash equals to yi dash equals to d means dash derivative. So it will be yi dash equals to 1 upon 2h yi plus 1 minus yi minus 1. yi double dash is equals to 1 upon h square yi plus 1 minus 2yi plus yi minus 1. Similarly, we can find yi triple dash, third order derivative, 1 upon 2h cube yi plus 2 minus 2yi plus 1 plus 2yi minus 1 minus yi minus 2, and the last fourth order derivative. This is the fourth order derivative. हा फोर्थ येतो पहा h raised to 4 d raised to 4 yi. h raised to 4 d raised to 4 yi म्हणजे यालाच असं लिहिता येतं, लक्षात घ्या. So d raised to 4 yi, d means derivative, d raised to 4 yi, h raised to 4 division मध्ये जातं 1 upon h raised to 4 in a bracket yi plus 2 minus 4yi minus plus 1 plus 6yi minus 4yi minus 1 plus yi minus 2. अशा पद्धतीने हा फोर्थ ऑर्डर डेरिव्हेटिव्ह घेतो. सो वी कॅन राईट दिस फोर्थ ऑर्डर डेरिव्हेटिव्ह इज, दिस इज ॲक्च्युअली फोर्थ ऑर्डर डेरिव्हेटिव्ह. वी कॅन राईट दिस एज, यालाच तुम्ही असं सुद्धा लिहू शकता d4 of yi. This is also written as a d cube of yi. This is also written as a d square of yi. and this is also written as d of yi or y dash, y dash, y double dash, y triple dash. This is the triple dash. मग आता हा 3 कसा आला, लक्षात आला का रे तुम्हाला? So we can write this is the third order derivative. This is the third order derivative. H cube into d cube yi. So we can write d cube yi is equals to 1 upon 2h cube yi plus 2. In this way we can write this, okay? So third order derivative will be 1 upon 2h cube in this way. From this we can write third order derivative, and from this we can write fourth order derivative. From this we can write second order derivative. So delta 2yi, second order derivative yi means 1 upon 2. This means that this is equals to, therefore d2yi means 1 upon h square yi minus 1 minus 2yi plus yi minus 1. This is equation number 3. आता इथं पहा hd, this can be written as dyi 1 upon 2h into yi plus 1 minus yi minus 1. So this is equation number 2. This is a 3, this is a 4, this is a 4, and this is a 5. So we can write this as, this is a from 2, this is a from 3, this is a from 4, this is a from 5. In this way we can obtain the fourth order derivative. So write down note. मग याला short note मध्ये असल्या dyi which is equals to yi dash is equals to 1 upon 2h in a bracket yi plus 1 minus yi minus 1, d2yi which is equals to y double dash is equals to 1 upon h square yi plus 1 minus 2yi plus yi minus 1, d3yi which is equals to yi triple dash is equals to 1 upon 3 factorial as it is. Similarly d4yi is equals to yi fourth derivative, this is the fourth order derivative, 1 upon h raised to 4 yi plus 2 minus 4 yi plus 1 plus 6 yi minus 4 yi minus 1 plus yi minus 2. In this way we can obtain the higher order derivatives, okay? ठीक आहे. Now we consider problems based on this. Now we shall discuss the problems. आता याच्यावरचे problems घेऊ. How we can write the problems here? Assuming Bessel's interpolation formula, obtain the following result. That means by using a Bessel's interpolation formula, we have to show that dyx by dx, dy by dx is equals to delta y suffix x minus 1 by 2 minus 1 by 4 delta cube y x minus 3 by 2 plus dot dot dot. We have to find out first order derivative by using a Bessel's formula. Now we know that the Bessel's formula is yx is equals to y0 plus y1 upon 2 plus x minus 1 by 2 delta y0 in the form of u. Actually आपण तिथं फॉर्म्युला u लिहिला होता, पण dy by dx काढायचं असल्यामुळं इथं तुम्हाला dy by dx च्या जागी u च्या जागी x घ्या. So yx is equals to x minus 1 by 2 delta y0, x in a bracket x minus 1 divided by 2 factorial delta square y minus 1 plus delta square y0 upon 2. This is the Bessel's formula in terms of x. That means we have to replace u by x because we have to calculate dy by dx. So replace this yu in place of yu, put yx, then this is the Bessel's formula. Now changing x to x plus 1 by 2. आता जिथं x आहे ना तिथं x plus 1 by 2 ठेवा. So this is as it is. आता इथं x च्या जागी जर तुम्ही x plus 1 by 2 ठेवलात आणि हा minus 1 by 2, so plus 1 by 2 minus 1 by 2 will be get cancel, it will be x. सेम प्रोसेस मध्ये या x च्या जागी x plus 1 by 2, या x च्या जागी x plus 1 by 2 minus 1, x plus 1 by 2 minus 1, which will be x minus 1 by 2. So it will be x minus 1 by 2 divided by 2 factorial as it is, delta square y minus 1 plus delta square y0 upon 2. Again this we can write x plus x minus 1 by 2, we can write this as x. This x is replaced by x plus 1 by 2 and this x minus 1 is replaced by x minus 1 by 2. Divide by 3 factorial as it is, delta cube y minus 1. So this completes the second step for x is changing into x plus y plus 1 by 2. So now we differentiate this. आता याचा differentiate करा. Now if we differentiate with respect to x, याचा derivative घ्या. So it will be, याचा derivative होतो 0. This is the constant term 0. x चा derivative 1. So it will be delta y0. It will be delta y0. आता या दोघांचा ब्रॅकेटचा प्रोडक्ट होतो पहा x square minus 1 by 4. Now multiplication of these two bracket is x square minus 1 by 4. आता याचा जर डेरिव्हेटिव्ह घेतला तर x square चा डेरिव्हेटिव्ह काय येतो 2x. That will be derivative will be 2x आणि हा 2 आणि हा 2 cancel होतं. The remaining term is x here. Here is the remaining term x. समजतंय का रे स्टुडंट्स पहा. आणि 2 फॅक्टोरियल म्हणजे 2 इथं ठेवला किंवा हा 2 कॅन्सल होता. हा 2 कॅन्सल करण्याच्या ऐवजी काय करा, this 2 and this 2 factorial will be get cancel. So this value of this total term, derivative of this is only x. Remaining term is as it is. Similarly you can multiply these 3 brackets. या 3 ब्रॅकेटचं मल्टिप्लिकेशन करा. x क्यूब येतं. मल्टिप्लिकेशन केल्यानंतर त्याचा डेरिव्हेटिव्ह घ्या. या टोटल टर्मचा डेरिव्हेटिव्ह यू कॅन कॅल्क्युलेट दिस. याला सॉल्व करा. तर टोटल डेरिव्हेटिव्ह ऑफ दिस टर्म इज x स्क्वेअर बाय 2 मायनस 1 बाय 24 delta cube y minus 1 as it is. Okay. Now putting x is equals to 0. x is equals to 0 ठेवा. x is equals to 0 ठेवल्यावर काय होतं पहा. See this. If we put x is equals to 0, then dy 1 by 2 dx is equals to, हे 0 होतं, that will be 0. हा 0 होतो. Then remaining term will be delta y0 minus 1 by 24 delta cube y minus 1. If we put x is equals to 0, then we get in the 6. Then we get, suppose this is equation number 1. This is equation number 1. This is equation number 2. This is equation number 3. Put x is equals to 0 in equation 3, then what will happen? So we can write, 1 minute. Suppose this is 1, this is 2, and this equation will be 3. So put x is equals to 0 in 3. x is equals to 0 in 3, then we will get dy 1 by 2 of dx, dy 1 by 2 with respect to x is equals to delta y 0 minus 1 by 24 delta cube y minus 1 plus dot 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 whatever may be. Shifting origin 0, आता origin आपल्याला शिफ्ट करायचे x minus 1 by 2. ओरिजिन कुठे शिफ्ट करणार x minus 1 by 2. ओरिजिन म्हणजे 0 च्या जागी 1 by 2 ठेवा, म्हणजे सबट्रॅक्ट करा 1 by 2. सो वी कॅन राईट dy by dx इक्वल्स टू डेल्टा y x minus 1 by 2 डेल्टा y x minus 1 by 2 minus 1 by 24 delta cube x minus 1 by 2. See this minus 1 होताना shift the origin केला x minus 1 by 2 minus 1, this minus 1 shift केला, so x minus 3 by 2. so we can write this as x minus 3 by 2. इथं origin shift केला, 0 होता o होता तो shift केला x minus 1 by 2, याला minus 1 होतं त्याच्यामध्ये प्लस ॲडिशन करा x minus 1 by 2 ओरिजिन शिफ्ट केल्यामुळं. सो दिस विल बी इन द फॉर्म ऑफ दिस आफ्टर शिफ्टिंग द ओरिजिन. सो दिस कॅन बी रिटन ॲज अ डेल्टा वाय एक्स, कारण फॉर्म्युला माहीत आहे पहा, डेल्टा वाय एक्स minus 1 by 2 we can write in the form of a delta, and this is in the form of a delta. So we can write this as delta yx minus 1 by 24 delta cube yx in this way, where a formula delta yx is equals to yx plus 1 by 2 minus yx minus 1 by 2. So we get this relation, and hence the final answer will be, so we can write dyx by, so we get dyx by dx which is equals to delta yx in this way, and which is our required proof. आणि हेच आपल्याला प्रूव्ह करायचं होतं. दिस इज आवर रिक्वायर्ड प्रूफ, पण हे प्रूव्ह होतं वर हे. सो वी कॅन राईट दिस इज आवर रिक्वायर्ड प्रूफ. सो दिस इज आवर रिक्वायर्ड प्रूफ अँड हेन्स प्रूव्ड. खूप सिंपल आहे, फक्त डेरिव्हेटिव्ह तुम्हाला घेता आला पाहिजे. ओके, नाउ वी शॅल मूव टुवर्ड्स द नेक्स्ट प्रॉब्लेम. व्हॉट इज द नेक्स्ट प्रॉब्लेम? फाइंड द फर्स्ट अँड सेकंड डेरिव्हेटिव्ह ऑफ द फंक्शन tabulated below at the point 3.0. We have to find out first order derivative and second order derivative by using the tabulated here y0. This problem we can solve in two different ways. By using Newton's Gregory forward interpolation formula, that means we can solve by using this. हे डेरिव्हेटिव्हच्या साहाय्याने सुद्धा सॉल्व करता येतं. You can use this, or we can use actual by taking the actual derivatives. You can use by taking actual derivatives. See this, we can take actual derivative घेऊन केलेला आहे. So table आहे y minus 1, this is the given table, this is the given data. Now this is the first difference, this is the second difference, this is third difference, this is the fourth difference, this is the fifth difference. Then again, sorry, this is the first order differences. Now this is the second order differences, this is the third order differences, first second third या मधला हा difference, and last is the fourth order difference will be 0, the final will be again 0, means delta Phi is equals to 0. No problem. Now by using Newton's Gregory forward formula, we can write in terms of x. Newton's Gregory forward formula we can write in terms of x, which is denoted by f of x is equals to f of a plus hx is equals to in this way. आपण ॲक्च्युअली हा जो फॉर्म्युला आहे, actually we have seen this formula in terms of u, but we have to calculate dy by dx, so we can write in terms of dy by dx f of x is equals to f of a plus x into delta f of a. Means here x means we have replaced u there. आपण ॲक्च्युअली घेत असताना u वापरलेला आहे. सो नाव डिफरन्शिएटिंग विथ रिस्पेक्ट टू एक्स, दोन वेळा याचा डेरिव्हेटिव्ह घ्या. याचा येतं फर्स्ट वेळा डेरिव्हेटिव्ह घेऊ अगोदर 0 होतं. याचा फर्स्ट वेळा डेरिव्हेटिव्ह घेतल्यावर काय येतं पहा. वी कॅन टेक दिस f dash of x is equals to, if we take the first time derivative or dy by dx equals to, याचा येतो 0, x चा डेरिव्हेटिव्ह किती येतो 1, मीन्स डेल्टा f ऑफ a प्लस एक्स स्क्वेअर मायनस एक्स आहे, आणि एक्स स्क्वेअर मायनस एक्स असतील तर त्याचा डेरिव्हेटिव्ह कसा लिहिता येईल रे. एक्स स्क्वेअर मायनस एक्स मीन्स एक्स स्क्वेअर मायनस एक्स डिवाइड बाय 2. मग याचा जर डेरिव्हेटिव्ह घेतला तर 2x मायनस 1 बाय 2 इंटू डेल्टा स्क्वेअर एफ ऑफ ए प्लस डॉट डॉट डॉट, हायर डिफरन्शियस काढून टाका, याचं पण मल्टिप्लिकेशन करा, होऊन जातं. म्हणजेच याचा डेरिव्हेटिव्ह येतो x मायनस 1 बाय 2 इंटू डेल्टा स्क्वेअर एफ ऑफ. दिस इज द थर्ड टर्म. अशा पद्धतीने याचे डेरिव्हेटिव्ह घ्या. पुन्हा आता सेकंड ऑर्डर डेरिव्हेटिव्ह घेऊ. नाव इफ वी टेक द सेकंड ऑर्डर डेरिव्हेटिव्ह एफ डबल डॅश ऑफ एक्स इज इक्वल्स टू, हा 0 तर आहे, याचा 0 होतो. याचा कसा येतो बा 2x चा डेरिव्हेटिव्ह 2x चा डेरिव्हेटिव्ह 2 कॅन्सल, प्लस डेल्टा स्क्वेअर एफ ऑफ ए प्लस इथं येतो. आता याचा डेरिव्हेटिव्ह घ्यायचा. याचा डेरिव्हेटिव्ह पुन्हा कॅल्क्युलेट करा. सेकंड ऑर्डर डेरिव्हेटिव्ह कॅल्क्युलेट करा. एक्सची काहीतरी टर्म येते इंटू डेल्टा एक्स क्यूब. डिफरन्शिएट 2 times with respect to x and putting x is equals to 0, then we will get the equation. असं इक्वेशन येईल पहा. h लेफ्टला घेतला. सो f dash of a is equals to delta f of a 1 by 2 delta square f of a 1 by 3 delta cube f of a minus in this way. So this is the first order derivative, this is the second order derivative. So second order derivative will be delta 2 f of a minus delta cube f of a plus 11 by 12 delta 4th f of a in this way. If we put a is equals to 3, h is equals to 0.2, a means 3, h means the difference between these two, then we will get, putting these values in equation 1 and 2, so we can write this as, ह्याच्यात ठेवा, पुन्हा ह्याच्यात ठेवा. So 0.2 f dash of 3 is equals to delta f of a. From the forward difference table, put this value delta f of a 1 by 2 delta square f of a delta cube f of a. Higher differentials remove kara. So we will get f dash of 3 is equals to 18. So first order derivative at x is equals to 3 is 18. Similarly, if we put second, आता second मध्ये ठेवा 0.2 ब्रॅकेट स्क्वेअर इथं ठेवा 0.2, h means 0.2, a means 3, so it will be, मग त्याची व्हॅल्यू असेल f डबल डॅश ऑफ 3 is equals to 0. हां समजते का रे. हे कॅल्क्युलेशन करायचे तुम्हाला स्टुडंट्स. So it will be f double dash of 3 is equals to 18. So we get, therefore dy by dx is equals to 18 and d2y by dx square is equals to 18 at x is equals to 3. अशा पद्धतीने डेरिव्हेटिव्ह काढायचे. परत एकदा पहा. हे दिस इज द फर्स्ट ऑर्डर डिफरन्स. One minute. This is the first order difference, this is the second order difference, third and higher order remove केले आपण, त्यामुळे इथं ठेवली ही व्हॅल्यू. 3.99n means delta f of a, delta square f of a means 0.786, डेल्टा क्यूब एफ ऑफ ए मीन्स 0.48 आणि हायरचे आहेत ते 5, 6 रिमूव्ह करून टाकले. इन दिस वे वी कॅन ऑब्टेन. अशा पद्धतीनं हायर ऑर्डर रिमूव्ह करा. डेल्टा 5 ची व्हॅल्यू 0 आहे. डेल्टा 5 मीन्स 0, डेल्टा 4 मीन्स 0, डेल्टा क्यूब मीन्स 0.48. ते सर्व 0 होतात, लिहायची गरज नाही आहे. ओके. इन दिस वे वी कॅन ऑब्टेन द डेरिव्हेटिव्ह ऑफ धिस टर्म. अशा पद्धतीने दिस इज ऑल्सो वन ऑफ द एक्झाम्पल, इम्पॉर्टंट एक्झाम्पल. Okay, we can find the derivative of this term at any place. Okay. अशा पद्धतीनं हा डेरिव्हेटिव्हचा हा सेकंड पार्ट होतो, मिडलचा पार्ट होतो. वी कॅन फाइंड द सेकंड ऑर्डर डेरिव्हेटिव्ह ऑफ द फंक्शन इन द टेबल बिलो. ओके. हे मात्र इथं कॅल्क्युलेट करा. थर्ड ऑर्डर डेरिव्हेटिव्ह, फोर्थ ऑर्डर डेरिव्हेटिव्ह सब पद्धतीनं व्यवस्थित घरी कॅल्क्युलेट करा, तुम्ही येऊन जाईल. यू कॅन कॅल्क्युलेट दिस. ओके. अँड दिस इज ऑल्सो the proof of first problem. This is the second problem, this is the first problem. हा first problem भी important type आहे, लक्षात घ्या. This is also important. ओके. तर हे पार्ट व्यवस्थित लिहून घ्या म्हणजे होऊन जातं. इफ यू हॅव एनी डाऊट देन यू कॅन आस्क. ठीक आहे. आता सर्वांचे सेमिनार चांगल्या पद्धतीनं चाललेले आहेत. सेमिनार स्केच पेननं व्यवस्थित लिहून चांगल्या पद्धतीनं करा किंवा PPT करा. चांगलं तुम्हाला ज्या पद्धतीनं सेमिनार चांगल्या पद्धतीनं करता येतो त्या पद्धतीनं सेमिनार चांगल्या पद्धतीनं करा. या नोट्स व्यवस्थित लिहून काढून पाठवा. व्यवस्थित लिहा, सुटसुटीत लिहा. प्रत्येक टर्म ही सुटसुटीत लिहायचं. नोट आहे ही नोट, सुटसुटीत लिहायचे प्रत्येक टर्म. हां, यू कॅन राईट ईच अँड एव्हरी टर्म व्हेरी ॲक्युरेटली अँड इन सुटेबल फॉर्म. ओके. ठीक आहे. and this is the first problem, this is also important problem, and this is the second problem, this is also important problem. Okay. Now we shall stop here. Now tomorrow we shall discuss the next part of this chapter, numerical interpolations आहे. ओके. डिफरन्सेस मध्ये तो आपण घेऊ. ठीक आहे. now we shall stop.